This video is for 6th grade math, lesson 115. It's our very last lesson for the school year, and you'll be taking your final test on Friday. So today we're looking at adding and subtracting mixed measures and multiplying by powers of 10. So for our mixed measures, sometimes we'll have to add and subtract measures that include more than one unit of measurement. If we say that a movie is an hour and 40 minutes long, we have used a mixed measure that includes hours and minutes. When adding and subtracting mixed measures, we may need to convert from one unit to another unit. So here's how we do it. Example 1, we have 1 hour and 40 minutes added to 1 hour and 50 minutes. So looking at our problem here on the board, we can only add together measures that are in the same unit. So we couldn't add, say, 40 minutes to, let's throw it out there, 50 seconds. Now we could say 40 minutes and 50 seconds, but we can't combine the numbers of the units, if that makes sense. So adding together our minutes first, always start with the smaller measurement, then go to your larger one. So 50 minutes plus 40 minutes gives us 90 minutes. 1 hour plus 1 hour gives us 2 hours. Now, 90 minutes is more than 1 hour. So what we need to do next is take our smaller unit and convert it into our larger unit. Now we know that there are 60 minutes in 1 hour, so we can subtract 60 from 90 minutes. That leaves us with 1 hour, that's our 60 minutes, and if we subtract 60 from 90, we're left with 30 minutes. So this converts to 1 hour and 30 minutes. Now we take our 1 hour and we add it to our 2 hours. 2 hours plus 1 hour is 3 hours. So our final answer is 3 hours and 30 minutes. So keep in mind, we can only add together our like measures. We cannot combine measures that are different. So add together smaller units first, then our larger units, and convert your smaller units to the larger units and get your complete answer. Example 2, we are subtracting feet and inches. So let's get this one up on the board. Not erasing very clearly, but that's okay. All right, so we have 6 feet, 5 inches. Minus 4 feet and 8 inches. Okay, so when we are subtracting our measures, we are going to often have to borrow from our larger measures, just like we borrow in normal subtraction. So notice that on top we have 5 inches and we're trying to subtract 8 inches from that. Obviously we can't subtract 8 from 5, we can't have negative inches here. So we need to borrow from 6 feet, convert it to inches, and then subtract. So we know that there are 12 inches in a foot. So we'll take away 1 foot. It's kind of along the same lines of how we borrow with fractions. You take 1 away from your whole number, convert it to the fraction that matches the denominator of your fractional part, and then we add everything together. So we borrow 1 foot from 6 feet. That leaves us with 5 feet here. We take our 12 inches from the foot that we borrowed here, and we add it to 5 inches. So 12 plus 5 gives us 17 inches. Now we can go ahead and do our subtraction. 17 minus 8 gives us 9 inches. 5 minus 4 gives us 1 foot. Now notice with this one, we don't need to do any conversion here because our 9 inches is already under 1 foot. So we can leave it as it is, and our final answer is 1 foot and 9 inches. So keep in mind, when we subtract, we'll often have to borrow from the larger unit of measurement and convert it into the smaller. So make sure you're also going over your units of measurements, and knowing those, it'll make conversion easier so you don't have to look it up every time you go along. All right, let's look at our powers of 10 next. Multiplying by powers of 10 is very, very easy. It's probably the easiest multiplying that there is. Multiplying by powers of 10 does not change the digits, only the place value of the digits. We can change the place value by moving the decimal point the number of places shown by the exponent. So we've done our types of notation before. So let's look at this next example. To write 1.2 times 10 to the third power in standard notation, we simply move the decimal point 3 places to the right, and we fill in our empty places with a 0. So it looks kind of like this. We have 1.2. We have 1.2 times 10 to the third power. Now remember, 10 to the third power means 10 followed by 3 zeros. So we change the answer by moving our decimal point 3 times. So we take our decimal point in 1.2 and we move it 1, 2, 3 times. We fill in our empty places with zeros, and we leave our understood decimal point all the way to the right of our answer. So therefore, 1.2 times 10 to the third power, our final answer equals 1,200. So remember to fill in those empty places with zeros. All we're doing is taking that decimal point, counting it off the number of places that we're given, and filling in those empty places with 0. Now, you can look at the rest of the examples there. Let's turn the page and see what it says here. Sometimes powers of 10 are named with words instead of numbers. For example, we might read that there are 5.2 million people living in Hong Kong. The number 5.2 million means 5.2 times 1 million. We can write this number by shifting the decimal point 6 places to the right, which gives us 5,200,000. So to see how we do that, all right, so we have 5.2 million. 5.2 million, and we would multiply it times 10 to the 6th power. So we're multiplying it by 1 million or 10 to the 6th power. And all you're doing is counting the zeros that are in your number. So in 1 million, there are 6 zeros. That gives us 10 to the 6th power. So then you take 5.2 and you count off the places for the decimal. 1, 2, 3, 4, 5, 6. Fill in zeros, and then our final answer is 5,200,000. And that is how you do that. So then example 4, write $500 million in standard notation. The expression half of a billion means 1/2 of 1 billion. First, we need to write 1/2 as the decimal number 0.5. Then we multiply by 1 billion which shifts the decimal point 9 places. So you can do these ones, and even the one that we just did with the 1 million. You can write it with more of the standard notation. So let's say that we were to multiply 5.2 times 1 million. You could still write it 5.2 times the 1 followed by 6 zeros. And when you do this, you're still just counting up the number of zeros and then moving your decimal point accordingly. So it's still 6 zeros, so you'd still take your decimal point, move it over 6 places, and fill in those empty places with zeros. Doesn't really change the answer at all. You can just write it in different forms of notation. So for the 1/2 billion, we'll take our 1/2 and we'll make the decimal 0.5 since that equals 1/2. Then we multiply by 1 billion, which shifts our decimal point 9 places. So again, you could do 0.5 times 10 to the 9th power. It means we're moving our decimal point 9 places. Or you can write out the whole thing like they do in the book here with the 1 followed by the 9 zeros. This is a little bit easier. You still understand how many places you're moving it, but you can really kind of do it either way. So if we take 0.5, we multiply it by 1 billion or 10 to the 9th power, we're moving our decimal point 9 times. So then that would leave us with 0.5, move our decimal point 1, 2, 3, 4, 5, 6, 7, 8, and 9. Fill in our missing places with our zeros. And we would be left with 500 million. 500 million is 1/2 of 1 billion. So that is multiplying by powers of 10. If you have any questions over this, make sure that you let me know. If you have any questions for the final test, it's not really a final, but it's the last test you're going to take. And there are some things on there that are, as always, that are reviewing over past lessons. So if there's anything that you're not sure on, any type of problem that you think you might need help with, just let me know so that you can do your absolute best on that final test. So that is our very last math lesson, and hope you guys have a great rest of your day. Good luck with all of your finals. I'm praying for you. I miss you guys a lot. I really wish we could have our normal end of the school year, but things are what they are. So hopefully we'll see you guys back in August. Have a great day.